All right, so in this activity, we've got 6 piecewise functions, 13, 14, 15, 16, 17, 18. We've got 6 graphs to match them up with. So I can't fit everything onto one shot, but to start off, what I'd like you to do is take 3 different opportunities and try and match up A, B, and C with one of the functions above. All right, so take a second and try that. Okay, so how I would go about this is I'm going to look for the sort of the dividing line of this function. So for A, I start here at 4, so then that means this is 2, and then that means that probably where this function splits is at x equals 1. Here, clearly it splits at x equals 0, and here, if that's 2, 0, this is negative 2, that splits at x equals negative 1. So that's going to help me narrow it down. So for A, I'm going to look at all the functions that change at x equals 1. So that's 18 and 15. So if I'm looking at the difference between 18 and 15, 18 has a horizontal line, and 15 are 2 diagonal lines, both positive slopes. This one has a negative slope and then just a flat line. So clearly, we're talking about A and 18. They correspond to each other. Right, I can check that. I can see that if the scale is 4, 2, 0, negative 2, negative 4, the y-intercept is right between 0 and negative 2. So that would be at negative 1, which corresponds right here to negative 1. And then it includes the function at positive 1. So right there is a filled-in circle, and then continues with an open circle, and it's always equal to negative 5 here. So definitely 18. Okay, so for B, now I want to find out where the dividing line is 0. So that's between 14 and 16. So if I look at 14, I've got 2 lines, same y-intercept, both positive slope. When I look at 16, I see both have a positive slope, but I've got 2 different y-intercepts. Well, if I look at the graph of B, both of these lines intersect at the y-axis. They both have a y-intercept of 4. So obviously, if these are both 4, B is going to correspond to 14. It's not obvious, but if these are different y-intercepts, these are the same, it's got to be that. Okay, last C. So I'm comparing, well, actually, I really should have looked at 13 when I was talking about A, because that actually also has a split at positive 1. But here I've got negative 1, and the only one that splits at negative 1 is C, so that's got to be C. All right, and just to double check that, when x is greater than negative 1, we've got 3x minus 1, y-intercept at 1, up 3 over 1, up 3 over 1. Yeah, that looks good. All right, and then the bottom half of that is negative 5. I'm sorry, is negative 5. So when x is less than negative 1, so yeah, that works too. So just double checking that C works there, and it does. Okay, so now we've got our next 3. So our next 3 functions, we've got D, where the dividing line is x equals 1. E, again, we've got a dividing line at x equals 1. And F, our dividing line is at x equals 0. So clearly, if I'm looking at these functions up here, F is going to refer to 16. Because here, where I'm splitting my functions at x equals 0, and that's the same case as you see here. So what's going to be difficult about, well, not difficult, but trickier about these two, they have the same dividing line, and both graphs have positive slopes. So what I can clearly see is the difference between these 2 graphs, though, is that we've got a different y-intercept. At D, this y-intercept is negative 2, And here, my y-intercept is -4. So whenever x is less than 1, I've got two different y-intercepts. So I'm looking here when x is less than 1. That's right here. When x is less than 1, right here. -4, -2 is my y-intercept. So looking back, I see, looking at these two graphs, D has a y-intercept of -2. So between 13 and 15, I'm going to choose 15 for D. For F, I'm sorry, did I say F? I meant E. For E, we've got our y-intercept of -4, so that refers to here. Okay, that's all for the matching.